Hello, welcome to the Tech for Good podcast. We are very passionate about two things, technology and our world. In each pod, we will be interviewing some fascinating people, business leaders, but those with a special interest in solving the biggest issues facing humanity today. Think the environment, think healthcare provision during a pandemic, think global social injustice. If you want to know more about technology's immense potential to fix and transform, then you're in the right place. In this episode, I speak to Dr. Atanu Chaudhuri. Atanu is a leading researcher in 3D printing technologies and has recently turned his focus to healthcare. As health systems worldwide come under huge strain, could 3D printing help alleviate the pressure? In the interview, Atanu runs through some of the applications for this technology in hospitals and gives his own thoughts on challenges and the future. But first, I ask Atanu about current adoption levels of 3D printing in healthcare.
Yes, so the first applications of 3D printing in healthcare was primarily in dental. We are not going to talk too much about dental today, but that's the most matured application of 3D printing in healthcare, which is in dental and dental aligners. There are a lot of already quite a wide adoption in dental industry. If you look at purely surgical applications, I can see that around more than 150 hospitals in US already have some form of 3D printing. Either they outsource the service or they have in-house 3D printing labs, which are managed by service providers, or they're completely managing on their own. So that's quite a sizable number of hospitals, 150. Now, coming back to UK and Europe, I see quite a bit of activities in Germany, in UK. In UK and NHS, I'll come back to that. There are some pockets where this is happening. Obviously, this is a different healthcare system, so we cannot really do it in the way where it is done in US. But in UK, Germany, Austria, Switzerland, there are hospitals who have been actively following this. Similarly, also in Asia, in India, Singapore, China, there are quite a few hospitals, possibly less than 10, but there are hospitals who are doing this. So we are still in the early stages, surely. But in the last 5 years, a lot of hospitals have adopted 3D printing for surgical applications.
Okay, and I'm looking forward to hearing more about those applications from you. But first, I know you've been leading recently a research program around the possibilities of 3D printing in healthcare. Can you give us a bit of an overview of that program?
So I started doing this when we had a small project. That time I was in Denmark, and we had a project with our universities in Israel. So it was a Denmark-Israel bilateral research program for 1 year, where we met different surgeons, we had workshops, we visited hospitals, and the objective was to mainly learn about the potential of this technology from the more operations side of thing. How does it improve efficiency? How does it really impact people's lives, both the clinical side as well as the hospital efficiency side? So we talked to a lot of people. Obviously, we are not medical experts, so it's important for us to understand that. So that's what we did. And based on that, I came out with a paper which talked about the outcomes and the benefits of this technology and how hospitals can invest. So there are multiple ways, as I told you, hospitals can invest in this technology. They can decide to outsource some of this service. They can decide to have in-house 3D printers, which can be run by a service provider, or they can even train their own juniors, resident doctors, and try to manage that on a lower scale. So there are multiple options. So we talked about how hospitals can adopt that technology. Now I am following sort of three strands based on what we learned from that project, and I'm trying to follow up and understand this interaction between engineering designers, product designers, and surgeons, which I find is very fascinating. It's very difficult, even for doctors for different specialties to interact with them, or engineers of different specialties to interact with them. Now we have engineers who have very little knowledge of the clinical side of things, interacting, working together with surgeons and developing some solution which is beneficial for the patients, right? So this is a fascinating form of interaction which happens. And so, what is the impact of this interaction on both clinical efficiency and on the hospital related efficiency? So, I'm trying to look at that. The next strand of research is around business models of these service providers who are providing these 3D printed related services for healthcare. And there are different types of models these companies are using. Some are, I'll talk about that a little bit later. So that's another strand. And the last one, I'm again trying to work with my contacts in Israel again for developing a simulation model to see how we can estimate the impact of use of 3D printing in a particular specialty within a hospital, taking data from that and showing that. But because once we are able to demonstrate that for different types of surgeries or with different patient characteristics, then it's easier for hospitals to adopt. Right now, they don't have a lot of hard evidence. Maybe some individual surgeons are trying and it has given some good benefits. There is a lack of scientific study on really coming out and quantifying some of the benefits, and that's one of our objectives. So these are the three strands of research which I'm currently involved in.
Okay, Atanu, it's really interesting and exciting work, I'm sure. What are the applications then, Atanu, of 3D printing technologies in a healthcare setting, and especially when it comes to kind of reducing, or its potential to reduce kind of strain on healthcare systems? Because we know, especially right now, healthcare systems all around the world are under that kind of strain. How could 3D printing technology help?
It's a very good question. So, as you know, any of the complex surgeries, which can be some complex cardiological procedure or orthopedic procedure, it takes a lot of time. As you know, some of the complex surgeries requires highly skilled surgeons and the paramedic team to work on it, and it takes maybe 6 to 8 hours to conduct such a surgery. And the reason why it takes such a time is a lot of uncertainty in the operating table. So when this team gathers together to conduct the surgery, they have limited information about the patient. They have done some planning, but what happens on the surgical table is very different many times. There are additional complexities which they have not envisaged, and that adds to the complexity and the time required. Now, if in any way we are able to reduce that time, that will help. And that's where exactly 3D printing comes in. If you are able to take the scan of the CT scan and the MRI and merge those together and able to really pinpoint the affected area of the patient, be it a tumor in the bone or some problems in the heart of a child, and then you can 3D print the anatomical model of that particular patient of that affected area. So it's very patient specific. I don't need to look at the CT and the MRI files and try to make sense of it by looking at these two different files. I can combine them, and then using that, I can print it. And with that physical model in hand, the surgical team can actually pre-plan the surgery pretty much exactly what the patient will face during the surgery. So that is one of the biggest benefits of 3D printing is in surgical pre-planning. With that, they should be able to shave off at least half an hour to 1 hour time. That's not a lot, but still half an hour, 45 minutes to 1 hour if you do only the anatomical model. Next is we can surgical teams are also 3D printing the surgical guides and the instruments. So that means even those instruments are not standard instruments. I am deciding that I will do the surgery exactly in this orientation. I will use a surgical tool from this side of the patient's heart and so on. And accordingly, I design a customized, bespoke surgical tool and an instrument or jigs and fixtures. If I do that, I can again further improvements, maybe another 1 or 2 hours being saved. Finally, if in some places, if I need to use an implant, say an implant in the leg, there is a trauma patient, there's an accident, the bone needs to be, uh, I need to fit an implant in the arm of a patient, even that implant can be customized. And if I do that, again, there can be potentially saving of time because I will be fitting exactly that implant and not something excess. I'll not cut excess bone in a normal situation. Sometimes the doctors have to take a little bit of margin of safety and maybe they will have to cut more bones. So all of these add up, and there will be saving in time in the operating theater, which in turn means that I am saving time for doing more surgeries. So that's one benefit. The next is, as these surgical implants as well as the surgical tools are customized, there is a high probability, in most cases it has been shown, that there is a very little chance of post surgical complications. In normally any such complex surgeries, there will be a lot of post-surgical complications because these implants are not exactly fitting a particular patient. They have to come back for multiple times for checkup and seeing and maybe doing another surgery and so on. All of these can be eliminated, which in turn means that the patient can get back to normal life pretty soon, almost within 1 week of doing a very complex surgery, which is quite a significant benefit. And that means it again reduces the strain on the healthcare system because the patient will not be coming back multiple times to address any post-surgical complications.
Hello, I'm Daniel Brigham, editor of Tech for Good magazine. I hope you're enjoying this podcast, and if you want more, you can head over to techforgood.net for some compelling and thought-provoking stories. From high-tech insect farms that could solve world hunger to a global mission to counter the spread of COVID-19 disinformation, we've got Tech for Good covered. You can read and subscribe at techforgood.net.
Well, Atanu, you've laid out there a number of really compelling kind of examples and benefits, which kind of begs the question, why has adoption still not been wider? Because, we know 3D printing technology isn't a new technology by any means. It has been around for many years. What do you think have been the biggest kind of hurdles, the biggest challenges in the past, and what remain the biggest challenges right now to getting this technology into a wider adoption?
Yes, I mean, as you can see, the anatomical model, I will say, is not very costly. So, a lot of hospitals are moving ahead with this plan of using anatomical models. But when you start talking about something which will go inside a patient, like an implant, or even using the surgical tools which will be used for a specific surgery, there is a cost associated with it, right? So, and in a public healthcare system, as in UK or in some other countries, we have to justify that cost. Still, when patient lives are important, and wherever we have a very strong clinical evidence and justification that we should do it, we will go ahead and do it. And that's exactly what is being done in NHS. I can see. In 100% of all the NHS trust hospitals, I don't think this will be adopted, or for every type of surgery, right? But I've seen applications in cardiology or orthopedics or oncology or in neurosurgery. There are almost 16 specialties. But for a public healthcare system like in UK, we have to have a very clear understanding which type of surgeries, based on what kind of complexities will we go ahead. In other cases, the cost might be still prohibitive, right? We cannot offer this to everybody for every type of surgery. It will not make sense at all. So that's why I see in UK, particularly those congenital pediatric cardiology cases, trauma cases where there is a very little chance of survival, or and where there is no other option, then 3D printing should definitely be used, and that's what being used. Now, if you don't look at the public healthcare system in different countries, which is not public, which is sort of paid by or insured, like in US, then the hurdle remains in ensuring that the reimbursement system is in place. If a hospital is doing this, that means the health insurance company should be able to reimburse that. And that is still under progress, and it's not 100%. So that remains a challenge. The next is obviously also the skills, right? We need engineers who can design these things, who have a very good understanding of the design aspects, as well as the clinical aspects, which is very difficult to get. I only found one person in one of the service providers who say that in their team they have ensured that 100% of the people have gone to an engineering school, and they have also have experience of spending some time in a medical school and doing some projects in a medical school, and they also understand the clinical aspects. That's not very easy, An engineer will not be a doctor, and a doctor will not be an engineer. And here you need skills of both, particularly from the service provider's point of view. Now, for surgeons, again, if they are completely dependent on these engineering companies and who are going to design or 3D print this, and they don't fully understand what are the limitations or what are the advantages, then that will also not going to work. So we need to train doctors, physicians, surgeons on at least some aspects of 3D printing, which is happening. There are some surgeons who are, particularly the younger ones, are very interested in learning this. And in Israel, when we visited a hospital, we saw that the interns, the resident doctors, there are some of them are specializing in 3D printing, and they almost know everything which an engineer does. So that person who's actually a trained physician is spending 1 year of his or her internship learning about 3D printing, learning how to do this design, learning to operate a 3D printer, everything, which is quite rare. So but we need skills, engineers learning about clinical things, and the physicians learning about the design skills. These are still some of the bottlenecks, some of the challenges. But on the economic side, as I have talked about, it is about the reimbursement. Is it about justifying the cost? And in some cases, it will be the cost will be prohibitive, and whether we can go ahead with that will remain a question. That's why there is a need of a very scientific study. And from the UK perspective, there is needs to be a plan or a position paper or strategy on how we should proceed with 3D printing, which kind of surgeries, under what conditions we should do. In other cases, we may not do, but I don't see a major obstacle in using anatomical models. That's easy. That's not going to the patient, and so on. That should be pretty much easy to use. Having said that, the other thing is also about this regulation. Moment something is going inside a patient as an implant, that is a medical sort of a class 3 type 3 medical device. That means that has to be validated, and there has to be a regulatory mechanism behind it to validate this, and that is still also a work in progress in most countries. So there are still some challenges, some ways to move ahead.
No, it's really interesting, Atanu, and obviously you're very passionate about it. And I'm interested in your personal background, how you've come to kind of be operating in this space. As you said, it's very much an engineering and a healthcare kind of worlds colliding. Tell us a bit more about your background and how you've come to where you are today.
Yes, so I'm a mechanical engineer by training. Obviously, when I graduated, I didn't know anything about 3D printing more than 25 years ago. But when I started reading about it, I was very fascinated about 3D printing. This seems to be an amazing technology, particularly for engineers, mechanical engineers, or designers to learn. So I spent some time learning the basics of this technology and so on. But my background was in manufacturing. So I worked always in manufacturing industry, in automotive. I did consulting for manufacturing companies. And most of my 3D printing related research is still obviously in manufacturing context, in industrial 3D printing, use of 3D printing for spare parts and so on. But healthcare is also a secondary research stream for me. I've done some prior work on healthcare efficiency, healthcare operations management, and I found that there are some gaps on use of digital technologies, and particularly 3D printing in healthcare. That's why I got interested, and I applied for that project I mentioned to you, and that's how it all started. But my background is in engineering, and then I did my PhD in operations management from India. I had many years of industrial experience, around 9 years, and then almost now more than 11 years of academic experience in India, Denmark, and in UK. So I am an engineer by training, now in the business school, and I also have an adjunct position in the engineering department in Denmark. So I'm always sort of a multidisciplinary person you can think of. And I don't claim to be any healthcare expert at all, but application of engineering as well as operations management in healthcare is something which fascinates me, and that's why I'm still interested in this topic.
Do you want to keep up to date with the latest in enterprise, technology, and digital transformation? Visit digitalbulletin.com for news, long reads, thought leadership, and so much more. That's digitalbulletin.com.
You said, though, that the challenges of kind of 3D printing adoption in healthcare, they are big challenges. You know, you mentioned the cost, you mentioned the skills. I mean, skills is a huge issue in technology, we know, but, you know, when it comes to healthcare, it's kind of, even more kind of critical, isn't it? Do you believe that we will kind of eventually get to a point where 3D printing technologies are kind of widely adopted? We will overcome these challenges, and that there will be benefits for patients ultimately.
Sure. I mean, it is happening, as you say. Already there are applications, and some hospitals are adopting it, and it's only a matter of time that we will see a wider application in particularly wherever it's needed. I firmly believe that technology again should not be sort of forced on in certain cases, because the doctors very well know that they have been doing these surgeries without 3D printing also, right? And most of these surgeries would have still been successful. But there were some challenges, as I mentioned, more time to do this surgery, more time to recover for the patient, and in some cases they will not have been able to do the surgery at all. So the first cases obviously are the ones where there was no other option, and if 3D printing is creating an additional flexibility, an opportunity to do the surgery and save lives, surely it will be adopted. For the other cases where there are options, I can still go ahead with a surgery in a conventional way, and where in 3D printing, these cost benefits have to be very specifically validated, and that's why I'm interested in such kind of studies to really show the benefits where it makes sense. And increasingly, hospitals will adopt this. Many surgeons nowadays are very passionate about this, interested about this, and they will adopt it wherever they think it makes the most sense. Now, these are one type of stakeholders, like the surgeons are still very interested. Now, the next is obviously the hospital administrators, and they will have to balance both the economic aspects and the clinical aspects, and both in a public healthcare system as well as in a private system. In a private system in India, where there are many different types of hospitals, I see even some hospitals investing in this technology. And if the volume or the demand is not so high for their own hospital, they are even using it to serve other hospitals, right? They use it as a way to earn more money. So they invest in this technology. They created a facility inside the hospital. And if maybe 60% of that facility is used for internal cases, and maybe 40% what remains, they will actually provide that service to other hospitals. And that is happening. I've already seen companies who talk to me about that. Wherever the demand is not so high, that these are relatively small hospitals, maybe a group of 10 hospitals together will have one 3D printing facility, and that is happening. And that's one way. Even these hospitals in Israel, they are talking about, they are providing services to hospitals in Jordan or UAE and so on. Because some of these things, the interesting thing is it can be done remotely. At least the design can be done remotely. It's always better to have local facilities, and it will surely happen over a period of time. And wherever it makes the most sense, it will be adopted. And we are already on that path, pretty much.
Okay, brilliant stuff, Atanu. And on a final point, really, I'm sure as an engineering kind of scholar as you are, you're interested in the wider kind of industrial revolution that's being brought about by technology, not just 3D printing, but things like, automation, robotics, artificial intelligence.
Yeah.
When you think of the power of those kind of technologies combining in a healthcare setting, the future is surely only positive, isn't it, in terms of creating better healthcare systems
Yes.
and better outcomes?
Yes, absolutely. There are multiple such applications in healthcare, AI applications for early cancer detection, which is a huge thing, right? So if you are able to understand the patient characteristics and create those artificial intelligence-based models to sort of predict whether a person is supposed to have a malignancy, a tumor, or a cancer in some form, this will give a lot of time. In most cancer cases, we don't have a lot of time. By the time the detection is done, it's already in advanced stage and nothing can be done. If you are able to save a lot of lives using AI, why not? And there are a lot of companies now which have been doing. Again, it's an early stage of adoption, but surely that is an application. I even see applications of, say, blockchain for avoiding counterfeit. I mean, counterfeit medicines and counterfeit medical devices are a reality in many parts of the world, particularly the developing world. And if you are able to track and trace the flow of the medicine as well as the medical devices, there are blockchain applications in that. I see also applications of in these kind of disadvantaged conditions where there is not much of basic healthcare in some countries in Asia, including India. There are a lot of applications of telemedicine. I also know a company which I've written a case about. They're going to the sort of the rural areas where there is very little basic healthcare, and they are collecting data about the patients. Even in this case, in COVID, if they're able to monitor the oxygen saturation level and then connect that using digital technology and connect this to some doctors sitting in in other locations and get some immediate help, all of this will help. So this company has been 5-6 years, and in working in India. I see some examples in Africa. So there are a lot of applications of digital technologies in also in situations where there is a limited public health infrastructure, and there is a lot of potential of digital technologies.
That was the Tech for Good podcast. Listen, subscribe, and rate us on Spotify, Apple Podcasts, and Stitcher.